formula to find out that. Yes. So in the same way, see, all these are statistical formulas. Now you have to remember this. Suppose this is how the variance is calculated. So this is a data and this is xi and x bar. Okay. So this is a formula which is used to find which one variance. So I'm not telling you the formula here. I'm just applying the function called variance of a which one here A. A is nothing but array. So if I'm trying to print variance, and what is the variance is 200.0. Suppose I take a simple array by saying np dot array, and here I'm writing 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. np dot variance of B. Now this is called as what here? Variance. So what is the value of variance is 2.0. But how the variance is calculated on flattened array? So return the variance of the array elements, a measure of the spread of a distribution is nothing but how far the number spreaded out of the mean. That is defined by using which one? Variance. Okay. Yes. But formula you have to apply it. The formula you have to apply. So these are some statistical operations or descriptive statistical functions, right? So after this, so let me tell you about, after this, let me tell you about so there are some functions here which are used for stacking. So there are some functions like stack, and there is a v stack, and there is a h stack, and there is a concatenate, and there is a function called which one? Append. So let me talk about these functions. The stack and vertical stack, horizontal stack, concatenate, and one more function is what here? Append. Append is one more function. So there is a stack. Now stack is nothing but concatenating. So it is nothing but concatenating along with the rows, concatenating along with what? Columns. So joining, stacking is nothing but what here? Joining. Stacking is nothing but what here? Joining along with the axis. Along with the axis, that can be rows or that can be columns. Now here the stack will do two things, like it allows stacking along with the axis, that can be rows or that can be what? Columns. That is done by using which function? Stack. So the name of the function is np dot stack. This is a function. Stacking is nothing but what? Joining. Stacking is nothing but what here? Joining. Okay. So what is the name of the function is np dot stack. So np dot stack is a function in the NumPy library used to join a sequence of arrays along with a new access. Okay, along with the new access means whenever you do the stack, it will try to change the dimension. It will try to change the dimension. If it is 1D dimension, then it is changed to what? 2D. If it is a 2D dimension, then it is changed to what? 3D, because it is trying to act along with a new access. So numpy.stack is a function in the NumPy library used to join a sequence of what here? Arrays. So stacking is nothing but what? Joining here. Okay. In the new access. Okay. So this numpy dot stack creates a new dimension in the resulting array. That is what I said just now. It will create a new dimension. Numpy dot stack creates a new dimension in the resulting array. Suppose what is the syntax of this? Okay, what is the syntax of this numpy dot stack? So the syntax of this numpy dot stack is np dot stack. You give the arrays. Now, if you want to join, you require more than one array. You require more than one array. So you need to give what here? Arrays. And comma, you have to give which one? Access. And what is the default access is? Here 0. Default access is 0. That indicates rows here. Default access is 0. That indicates what here? Rows. Here it is 0 means what? Rows. Access 0. Default access is what here? 0. So stacking is nothing but joining. Stacking is nothing but what here? Joining. You are joining along with the access. For example, assume that, there is an array np dot array. Now this is an array with some 3 elements. This is 1D array. So b equal to np dot array, and this is one more array. Okay. So these are 1D arrays. One dimensional array A dot n dimension and B dot n dimension. So what is the dimension of this both arrays? 1, 1. Okay. Now these are the elements of this array. I'm saying A comma B, A comma B. Now this is an array called A. This is an array called A having how many elements? 3 elements. And this is an array called B and having how many elements? 3 elements. So after that, I'm writing here C. It will return new array np dot stack. np dot stack. You need to give the arrays in sequence. Sequence means I'm giving it as a tuple. So where you are writing this arrays in tuple, it means you are joining A array and what? B array. You are joining which array? A array and what? B array. Stack is nothing but joining. Okay, you are joining A array and what? B array, and into which array? C array. But it will join as which as a rows or columns? Rows. It will join as a rows here. So what will happen is, now you can see it is added as a rows here. How many rows are added here? 2 rows. Okay, now this is one row and this is what here? Another row. So it is created arrays here. It is created array. Okay, adding this two arrays as what? Rows. Means this is 1D, this is 1D, but this is what here? 2D array. This is 1D array, this is 1D array, but this is which array? 2D array. Because you are adding this arrays as what here? Rows. So it is change the dimension or not? Yes. It is change the dimension here. It is change the dimensions here. Create a new dimension in the resulting array. Okay. So if you are trying to say print C and C dot n dimension, what is the dimension of this array here? 2. Now you are writing it as a rows. If I am writing a D equal to np dot stack. So what is the meaning of access 0 is row wise. What is access 0 here? Row wise. Okay, I'm writing a stack A comma B. I'm writing A comma B comma access 1. A comma B access 1 means you are adding it as what? Columns. Access 1 means you are adding it as what? Columns. Now if you see the D, you can see 1, 2, 3. So here 1, 2, 3, 10, 20 and what? 30. Okay, shape is what now? This shape is what? 2 by 3. And this shape is what? 3 by 2. Because here these elements are added as a rows or columns. Columns. Here 1, 2, 3, 10, 20, 30. Here it is a row. It is a row, but here it is what? columns. So the shape of this both are not same, right? If I'm trying to say C and C dot, now how you want to join? You are defining that by using access. This access can be either 0 or this access can be either what? 1. Okay, it can be 0 or it can be 1. This is when you are working with uh, 1D array. This is when you are working with 1D arrays here. This is, sorry. If I'm saying D dot dimension, now this is 2 comma D, sorry, D dot shape. What is it? 3 comma 2 is nothing but 3 rows and 2 columns. No, this is access 0. Now this is what I'm telling you. Access 0 means when it comes to this 1D array, access 0 means rows only. Either it is 2 or 1, it is rows. Represents what here? Rows. And axis 1 represents what here? Column. Now this is 1D array. Now let me talk about working with which array? 2D array. So let me talk about working with the 2D array here. But it will change the dimension. Suppose if you are stacking 2D array, then it will change to what? 3D array. For example, if I'm writing A, so np dot array. So this is an array with 1 comma 2 comma 3, 4 comma 5 comma 6. Now this is a matrix. So what is this here? Matrix. This is a matrix. Contain how many rows? 2 rows and 3 columns. Okay. This is a matrix contain 2 rows and 3 columns. And I'm writing a B equal to np dot array. np dot array. And here I'm writing 7 comma 8 comma 9. Okay, 10 comma 11 comma 12, right? So this is also 2D array with some 2 rows and 3 columns, right? So how many matrices are there? 2 matrices. One is A and one more is what? B. One is A and one more is a B. Now you want to do the stacking here. Okay. So here I'll say C equal to NP dot stack. NP dot stack A comma B. A comma B, I said, what is the default access is 0. What is the default access is 0. It means it will add these 2 matrices as what here? Rows. It will add these 2 matrices as what? Rows. Okay, it means when I say print C, you can see this is which array now? 3D array. This is which array here? 3-dimensional array. Now in this, it is added how many matrices here? 2 matrices are added. How many matrices are added? 2 matrices. And each matrix is having how many rows? 2 rows and 3 columns. Okay, 2 rows and what here? 3 columns. Okay, you can see that shape of this array. So print C dot n dimension and print C dot what is that here? Shape. Now you can see the shape of this array is 2 rows, 2 matrices, and each matrix is having 2 rows and how many columns? 3 columns. 2 rows and how many columns? 3 columns. Yes. Understood? Now stacking, whenever you do whenever you do stacking by using this function called stack, it will change what here? Dimension. Okay, right? When you stack a 1D array, it will change to what? 2D array. If you stacking is nothing but joining, right? So you are joining 2 arrays. You are joining 2 arrays by using a function called stack. So sometimes when you are working with the data science, okay, you may have a data in 2 different arrays and you want to combine those into what? One array. Then what do you do it? You can combine or you can join it by using a function called which one? Stack. Yes. Yeah, I think you understood this is a stack. It's nothing but joining. Now there is one more function is there. There is one more function is there, and np dot, what is the next function is np dot v stack, vertical stack. Now here I've taken in this example, what is the default access is? What is the default access is? 0. 0 means what here? Rows. Here default access is 0 and that access 0 is the rows. And if you want columns, then change it as what? Access 1. Understood? Right. So there is a np.h stack, horizontal stacking. np.h stack. So when you are working with this h stack, so it doesn't change the dimension here. In this case, it will not change the dimension. It just add the elements. You want to add the elements either row wise, or you want to add the elements either what? Column wise. That is done by which function? H stack. Yeah, this one you understood, right? So there is a function called H stacking. Joining. Stacking is nothing but joining. Horizontal. H stack or V stack. Anything you take V stack. Okay. So I just take definition from here. I don't want to write my definition. np dot V stack. So vertical stacking. V stack is nothing but row wise. H stack is nothing but column wise, right? So numpy dot vstack is a function in the numpy library used to stack arrays vertically. Vertically means row wise. From a single array for a sequence of what? Input arrays. Single array to sequence of what? Input arrays. That is done. Now that is different. Here it is different. Del. Here it is different. Here it is different. In this case, it is different. Understood? In this case, it is different here. Okay. Yes. So here there is no access. Here you don't define any access, right? So if you see the syntax of this np dot vstack, so np dot vstack, np dot vstack, np dot vstack, you give the sequence of arrays. You are giving the sequence of arrays, but here you don't define the access because vertical itself represents what? Access. Okay, right? So see here, forming a single array from a sequence of what here? Input arrays. It will create one new array. It will create one new array. It will create one new array. So what is the meaning of this? For example, assume that, see, whenever you are talking about stacking, in stacking, access 0 is what? Rows. Access 1 is what? Column. Remember this. See, somewhere they may give, if you see this, you can see it combines the array along with the first access. What is that first access is? 0. Understood? Right? So you have to, now when you are doing a stacking, right? Whenever you do stacking, what will it do? It will not change dimension, but it will change what here? Shape. Shape is nothing but number of elements in each dimension. Shape is nothing but number of elements in each dimension, that you call it as what? Shape. For example, see here. Otherwise, there is one array, np dot array, np dot array. Now this is an array having 3 elements. Okay, this is an array having how many elements? 3 elements are there. And here I'm creating one more array, np dot array. Now this is one more array having how many elements? 3 elements. If I'm writing a C equal to NP dot V stack, NP dot V stack, you have to give this as a sequence of arrays. Means include this either in list. This arrays you have to include either in list or you can include in what? Tuple. So how many arrays you are joining here? Two arrays. How many arrays you are joining? Two arrays. One is A and one more is a B. So what you are doing is you are trying to say print A comma B comma C. It means it will add all these elements. It will join all these elements how? Row wise in one row. Okay, now you can see vertical stacking. Now this is row and having how many things? Now this is 1, 2, 3 and this is what? 10, 20, 30. This is 1, 2, 3 and this is what here? 10, 20, 30. See here. This is A and this is B and I'm saying C equal to NP dot vertical stack. I'm trying to add these two arrays as what? You are adding this, you are joining these two arrays into what? Vertically. Vertically means what? Row wise. Vertical is nothing but what? Row wise. Now is it, this is doing the same thing as a stack? Is it doing the same thing as a stack with access what? 0. It is doing the same thing as access 0. Access 0. Access 0 is nothing but what here? Rows. Access 0 is nothing but what here? Rows. Vertically. So in the same way, if I'm taking another, see, NumPy provide multiple functions, specialized functions only used for specific. Vertically, you want to do it, just go for which one? V stack. Horizontally, you want to do it, just go for which one? H stack. Okay. Suppose there is an array, np dot array. So np dot array, see here, np dot array, I'm writing here 1, 2. Now this is a 2D array. So there is a 1, 2, comma 3, 4. There is a 1, 2, comma 3, 4. See here. So this is one matrix with the 2 rows and 2 columns. With the 2 rows and 2 columns are there here. Okay. Then I create one more array. So np dot array, again I'm creating 2 rows and 2 columns. So 2 rows and 2 columns and I'm saying np dot v stack, vertical stack. Here I'm writing x comma y. Here I'm writing x comma y and print x comma y comma z. I'm just using the separator as a new line here. So this is added as a rows or not? Yes. Now you can see which one it is. Now see, this is an array. Now this is one array. This is a matrix with 2 rows and 2 columns. And this is a matrix with 2 rows and 2 columns. You can see this is a matrix with how many rows? 1, 2, 3, 4. That means the elements of this arrays are added as what? Rows. But is it change the dimension in this case? Tell me, in this case, is it change the dimension or not change the dimension? Not change the dimension. It is changed only what? Shape. So it means it is adding the elements of this arrays as what? Rows. See here, this is an array contain how many rows? 1, 2, 3, and what is that? 4. But in this case, it is added these 2 rows as what? One array. Now in this case, it is converted into which array? 2D array. When you work with what? 1D. But when you are working with a 2D array, what it is doing? It is trying to add this array elements as what? It is trying to add this array elements as what? Rows. It is trying to add this array elements as what? Rows. Now it is having how many rows? 4 rows with how many columns? 4 rows and how many columns? 2 columns. 4 rows and how many columns? 2 columns. Right? So that is what will happen when you are trying to do vertical stacking. That is what will happen when you're doing vertical stacking. See here, it is creating one array. It is creating one array, but in this array, it is adding this array elements as what? Rows. Now you can see there is 1 comma 2. Okay, there is what here? 3 comma 4. Okay, there is what here? 10 comma 20. Okay, there is what here? 30 comma 40. So how many rows are created here? 4 rows. With how many columns here? 2 columns. Now that is nothing but which one? Vertical. But when it comes to the stack, if you are doing a stack of 2-dimensional array, it will change it to which array? 3-dimensional array. It means it will stack it, but it will try to add complete it will try to add complete, it will try to join the complete matrix. It will try to join the complete matrix as what? Row. That is what will happen when you are working with which one? Stack. It means these two are joined as a row in one array. So this is what will happen when you are working with the stack. But when it comes to the V stack, it will try to add, it will try to join which one? Array elements as what? Rows. Array elements as what here? Rows. That is done by using which one? Stacking, right? So vertical stacking, but here it is changed only what? Is it changed the dimension or shape? Shape is changed because it is added this array as what? Rows. It is added array elements as what? Rows. That is what will happen when you are working with vertical stacking. See here. If it is, see here, shape compatibility. The arrays with the sequence must have the same shape along with all the dimensions, the first axis. For 1D array, they must have the same length. 1D array handling is, see, this is what will happen. When 1D array, we stack automatically reshape to what? 1 comma n. 1 comma n. 1 comma n before concatenation, treating each 1D array as a single row. Is it done the same thing or not? See here, each single dimensional array is treated as one row or not? Yes, here one row it is treated. But when it comes to the 2D array, when it comes to the 2D array or 3D array, it will take each element as what? One row. Each element as what here? One row. See here, this is all the rows are vertically stacked. All the rows are vertically stacked into what? One array. That is done by using which one? Vertical V stack. Understood? But only for 1D array. But 2D array or 3D array, it will try to stack what? Vertically. Either row wise, only row wise, because V means vertical. But you cannot do it column. If you want to do column, then go for which one? H stack, which is nothing but horizontal stacking. But this point you have to remember when it comes to the 1D array. When it comes to the 1D array handling is this. This is what you have to remember here. So this is actually a note for this. 1D array handling, when stacking 1D array using VStack automatically reshape them toward 1 comma n before concatenation, treating each 1D array as a single row in the resulting which array? 2D array. This is 1D array. Okay, na? Yes. Yeah, understood. Bolo here, you understood this? With stacking, so will it change the dimension? No, it will not change the dimension, but it will change only shape. But when you are working with the 1D array, then compulsory it will change the dimension to what? 2D. Okay, it will change the dimension to 2D when you are working with the 1D arrays. Okay, right? Clear? Yes. Yeah. So, yeah. So this is when you are working with only 1D array, but 2D array anyway, it will add as a rows. Yes. Now, in the same way, the way how you are doing vertical stacking, in the same way, you have which one? Horizontal stacking. Horizontal means column wise. Yeah. See, whenever you're talking about joining, right? So in joining, which one is compatible? Shape compatible. The arrays within the sequence must have the same shape along with all the dimension except what? First axis. It should be same. The number of values should be what? Same. Okay. So that is what you have to remember here. Okay. So shape compatibility matters here. See here, the arrays within the same sequence must have the same shape along with all the dimension except what? First axis. For 1D arrays, they must have the same length. Okay. So the number of, okay, let me tell you this also. Compatibility. Let me tell you this also. If it is having two different shapes, if it is having two different shapes, what will happen? See here. For example, I take two arrays. NP dot array. Now this is 1D array with three values. Okay, 1D array with three values. Okay, NP dot array. Now this is with the two values. Means this is having how many values? Three values. And this is having how many values? Two values. But both are 1D. Both are 1D only. Now if I'm saying A dot n dimension, B dot n dimension. Okay. Now here I said A dot is shape and then B dot what is it? Shape. Okay. Now this is having three values and this is having two values, but both are dot comma. Sorry. Now you can see 1 comma 1, 3 comma what is it? 2. 1 comma 1 and 3 comma 2 and C equal to NP dot what is that? Vertical stack. NP dot vertical stack A comma B. Means it will add this as rows, but this row is having how many columns now? 3. But this row is having how many columns? 2. If I run this, now immediately it is given what? Error. Saying that value error is there. See here. All the input arrays dimension except the for the concatenation access must actually see here. But along dimension 1, the array at index 0 has a size 3 and array at index 1 has what? Size 2. So is it dimension, I mean, is it dimension compatibility issue is there or not? Yes. Shape. What is the shape of this is? What is the shape of this array is? See, what is the shape? 3. What is the shape of this is? 2. Okay, this is shape is a 3. This is shape is what here? 2. What is the size of this is? 3. How many values are there in A? 3 values. How many values are there in B? 2 values. But when you do vertical stacking, it will add this both arrays as rows or not? Yes. It means 2 rows. How many columns? How many columns? It cannot broadcast it. It cannot broadcast. So immediately it is given what error. What is that error is? Value error. Immediately it is given which error? Value error. Value error you can say it. Okay, na? So this is what you have to see when you are doing which one? Stacking. When you are doing stacking. Now if I am writing 4 comma 5 comma 6, so is it rows? So the number of values are same or size is same or different? Same. Then is it vertical stacking is done or not? Yes. Understood? Right? In the same way, now suppose, okay, I'm taking X is one array. Now, whenever you talk about this, compulsory it will look for which one? Shape compatibility. The arrays within the sequence must have the same shape along all the dimension except what? First axis. First axis is what? Suppose number of rows. Number of rows. But number of columns must be what? Same. But number of rows might be different. Okay. Suppose np dot array. Now see here. This is matrix with 1 comma 2 comma 3 comma 4. Now tell me it is having how many rows and how many columns? 2 rows and 2 columns. Okay, no problem. Now y equal to np dot array. np dot array. Now here I am saying 5 comma 6. Now tell me it is having how many rows? One row and how many columns? Two columns. Now first axis is what? Row. First axis is what? Row. Is it rows are equal or not equal? Not equal. No problem. But columns must be same. Getting on. Now, is it stacking is done or not done? Done. If I'm writing np dot, sorry, z equal to np dot, v stack, a comma b, sorry, x comma y. If I'm writing x comma y, it will stack vertically into an array Z. So in this case, you don't get any errors here. How many rows are added? 3 rows. Getting on. So first axis can be anything, but axis 2, which is axis 1, which is nothing but what? Columns. Should be what here? Same. So that is a rule which it will try to follow it when it is doing which one? Stacking. Okay, na? So this is a rule. Okay, anyway, this rule also will take it. So what is the next one is? So this is one more note. So whenever you are doing vertical stacking, it will also check for which compatibility? Shape compatibility. The arrays within the sequence must have the same shape along with all dimension except the first axis. But for 1D arrays, they must have the same length. Is nothing but number of length is nothing but number of values or number of elements. Length is nothing but number of values or number of elements. That is called as which one? Length here. That is called as a length. Now this compatibility also it will check. So 1D array you have to remember. So 2D array also you have to remember, but you should have rows should be the same. Rows can be anything, but columns must be what here? Same. First axis must be same. Okay. Remaining first axis can be anything, but remaining axis must be same. So same shape along all the dimension except what? First axis. Yes. Understood? This is shape compatibility. And this one is what? For 1D array handling. 1D array handling, and this is shape compatibility. So the way how you are doing VStack, in the same way you are doing HStack, horizontal concatenation here. The stacking internally using concatenation function, joining or concatenation, right? HStack is nothing but what here? Horizontal stacking. Means it will do stacking how? Row wise, column wise, column wise. It will do stacking how? Column wise it is done. It will do column wise. That is done by using HStack. So it means what is the default access it will take? 1. What is the default access it will take? 1. 1 is the access it will take. So axis 1, it will take horizontal axis. or the second axis. And what is the second axis here? Column. So numpy dot hstack is a function in numpy library for Python that is used to stack arrays sequence of horizon column wise. It combines the sequence of arrays along their horizontal axis, that is the second axis, which is nothing but axis 1 for which arrays? 2D arrays. For 1D arrays, it concatenate them along with the first axis. What is the first axis is? Rows. So the first axis is what here? Rows here. Yeah, just remember this. H stack and one more is what? V stack. Yeah, here no access. You just give what H stack. See here. NP dot. What is the syntax of this is? You are trying to write NP dot or numpy dot H stack, and here you have to give the arrays. You have to give the sequence of arrays. Now this is a syntax for horizontal stacking. Okay, this is a syntax for horizontal stacking here. Okay, now let me tell you about this. Now NP dot, I'm creating an array of one dimension with three values. So B equal to NP dot array. Now again I create with how many values? Three values. So here I'm trying to print A comma B. A comma B, and I'm using a separator here. You can see this is an array A having how many elements? Three elements. And this is an array B having how many elements? Three elements. And I'm writing a C equal to NP dot H stack. Horizontal stacking means these are joined as what? These are joined as what? Columns, right? So what will happen if I say print, you can see print C, these elements, put in sequence. So you have to group in a sequence, right? You can see these elements are added as what? Columns. But in this case, you should not think that, see, these are columns, may change it. How many values are there here? 6 values. But is it change the dimension? No, it is not change the dimension, but it is changed what here? Shape. Because it is add all these values as what? Columns. Understood? Right? It is add all these values as what? Column. Now you can see 1, 2, 3, 4, 5, 6. Getting on not? So there, if it is comes to a V stack, vertical stack, each array is added as what? Row. Each array, each 1D array is added as what? Row. But when it comes to the horizontal stacking, it is added elements as what? Columns. Now that provision is there here, right? Because how many rows are there here? One row with how many columns here? This is generally you'll say three values. This is what? Six values. Okay, it means it is having three columns. It is having three. Now you are adding this, you are joining this both the arrays as what? Columns. Now how many values are there here? Six values. This is possible. But here in VStack, it is not possible because you are writing it as what? Rows. You are writing it as what? Rows. But here you are writing it as what? Columns. Then here it concatenation is possible. But in this case, it will add this as what? two different rows. So see here, that is the difference what you find when it comes to which one? Horizontal stacking. Whenever you do stacking, it will do only the shape. It will change the shape, but it doesn't change as what? Dimension. Okay. Whenever you do horizontal or vertical stack, except when you work with vertical stacking, except 1D arrays, it will change only what? Shape, but it doesn't change as what? Dimension. Okay. Are you getting or not? Except 1D array, because you are joining rows. But when you talk about 1D array, it is having one row only, right? Yes or no? You cannot change two. You cannot change. You cannot concatenate with what? Two rows. If you are joining two rows, then it will become what? 2D array. If you are joining two rows, then it will become what? 2D array. But if you are joining columns, then it is 1D array. Only it will join all the values. Now you can see 1, 2, 3, 4, 5, 6. So how many values are there? 6 values are there. Suppose if you are working with the 2D array, np dot array, you can see here 1 comma 2, 3 comma 4. That is where you find the difference between stack, v stack, h stack. Stack join arrays into one array. It will combine arrays into one array. Means if you are combining two 1D arrays, it will become what? 2D array. If you are combining two 2D arrays, then it will become what? 3D array. If you are combining three 3D arrays, it will become what? 4D array. That is what will happen when you work with what? Stack. But here it doesn't changes the dimension, but it changes what? Shape. That is the difference between this both, right? So y equal to np dot array, y equal to np dot array, and here I'm writing some 5 comma 6 comma something like 7 comma 8. So this both are two dimension only. X dot n dimension, x dot n dimension, y dot n dimension. I try to print x array and y array. Now dimension of this both are same, and x dot shape is two rows and two columns. X dot shape is two rows and two columns. Y dot shape is again two rows and two columns. Here two rows and two columns, and yes, it is a 2D array. So I print x comma y. I print x comma y here. You can see is a 2D array with two rows and two columns, and this is also two rows and two columns you have. Okay. Then I'm writing a z, z equal to np dot, what is this? H stack, horizontal stacking. H stack, now give a comma b, sorry, x comma y, x comma y, x comma y, and print z. Okay, now actually it is having how many rows and how many columns? Two rows and two columns. Two rows and two columns. Now when I say Z, now it is having how many rows here? You can see this is having how many rows? Two rows only, but how many columns? Four columns. Means change its shape or not? Because it is added these elements in column or rows column. These are concatenated or joined these elements into one column, right? 1, 2, 5, 6. See here 1, 2, 5, 6 and 3, 4, 7, 8. 1, 2, 5, 6, 1, 2, 5, 6, and then 3, 4, 3, 4, what is that? 7, 8. Understood? So that is what will happen when you are working with the horizontal stacking. It doesn't changes dimension. It changes only shape, because it changes which shape? Columns only, because you are adding elements in what? Column. You are concatenating as columns, right? So it will change only which one? Number of columns, number of values when it is 1D array, number of columns when it comes to what? 2D array. So that is what will happen in horizontal stacking. Clear? Okay, now you have to understand the difference in stack and V stack and H stack. Okay. So there is also, so this is useful when you have a data in two different data sets. and you want to merge or you want to concatenate, you want to merge or you want to concatenate, then you can do that by using hstack and vstack. But say, for example, suppose with the different dimensions are there. Okay. So A equal to no problem here. A equal to NP dot array, because not rows, right? Not rows, but it is what? Columns, right? So here it is having how many values? Two values. NP dot array. So NP dot array, I create an array with 3, 4, 5, 6. How many values? 4 values. And C equal to NP dot, NP dot which one? H stack. What will happen? Will it give any error? Tell me, will it give any error? Now just to run this. Is it any error or no error? No error, because you are joining as what? Columns. So what will happen? A comma B comma C. You can see A is 1, 2, B is 3, 4, 5, C is 1, 2, 3, 4, 5, 6, because you are adding it as what? Columns. Understood? Right? So please try to understand this. Horizontally, columns. So here compatibility, no compatible issue here. See here. Handling arrays various dimension, useful 2D arrays where the number of rows must be consistent across all arrays being stacked. For 1D array, it will do the concatenation. That's it. Okay, right? Yes. Horizontally means side by side. Okay. So no problem here. Take this with a different shape. So this is with a different shape you have. Different shapes. No problem if it is having x equal to np dot array. So this is a matrix with 2 rows and see here, 2 rows and 2 columns. Okay. So y equal to np dot array. Here it is having one row with how many columns? 3 columns. So but dimension is same, but shape is what here? What will happen? Will it do a? This will give an error or not? Yes. Okay. If I am writing a z equal to np dot, what is this here? H stack, horizontal stacks here. Horizontal stack x comma, what is it? Y. X comma y. Now immediately it is given what? Sorry. This should be put in a sequence. X comma y. And if I run this, now immediately it is given one error. What is that error is? Value error. Because this is having 2 rows and 2 columns, and this is having 1 row. 1 row with how many columns? 3 columns. So the number of rows should be same or not? Yes. Number of rows should be the same. Suppose number of rows and columns both must be the same or not? Suppose this is having how many values? 3 values. Now suppose assume that I take same dimension is the same, but I'm taking different shape. This is having 2 rows and 2 columns, and this is having 3 rows and 2 rows and 3 columns. Now I'm doing horizontal stacking. Even I'm doing horizontal stacking. See here, I'm doing horizontal stacking. Now, is it given any error? No. But whenever you are whenever you are horizontal stacking 2D arrays, which axis to be matched? Axis 0 means first axis is nothing but number of what? Rows. Number of rows. Number of rows should be what here? Same. X comma y comma. I'm writing x comma y comma z. X comma y comma z, because you are adding these values as a columns here. 1, 2, 10, 20, 30. Okay. 3, 4, 40, 50, 60. This is no problem. But which one should be the same? Axis 0. First dimension must be same. Getting or not? Right? That is a rule which has to be followed when you're doing stacking. Now, which stacking it is? Horizontal stacking. Right? If it is 1D array, no problem. But if it is 2D array, axis 0 must be same. First axis must be same. Okay. Because you are writing it as a columns. Okay, this is clear. This is called which one? Horizontal stacking. So that is nothing but second axis, which is nothing but column wise. And V stack is row wise. But it doesn't changes dimension, but it changes shape. Means it will add the elements within the array. Along with the rows, it will add the elements within along with the rows. It will add the elements along with the columns. But dimension will be the same. Dimension will be the same. Okay, clear? Bolo here, yes or no? Okay, so that is about stack, H stack and V stack. So there is stack, V stack and H stack, and there is concatenate is there. So one more function, see. So concatenate. Now stack internally uses which one? Concatenate only. Concatenation. Okay, concatenate. So what is the name of the function is np dot numpy dot concatenate. So this is useful when you have a data in two different data sets. Okay, when you have a data in different data sets and you want to combine into one set. You want to combine into one set, then you can use these stacking functions. So numpy dot concatenate. Now this is also do the same thing. The way how you are using np dot stack and all the things, right? Same thing is done by this. But this is somewhat older function. Concatenate. Okay, now you can see. So concatenate function in Python library is used to join. See here, it is also used to join. Now it is also used to join. Now this function is a fundamental for combining and manipulating data stored in what? NumPy arrays. Simple definition. See, I can also give the definition, but I want to give technical definition so that you can say technically. That's one statement I can write. Concatenate is what it will join the two sequence. Pura same write the definition. Stack is concatenating. V stack is for concatenation. H stack is also for concatenation. Concatenate is also for concatenation. What differences are there or not? Yes. So what is the syntax? What is the syntax of this is, okay, np dot or numpy dot concatenate, you can give a sequence of arrays, and here you can give the access along with the access. But what is the default access is 0. What is the default access is 0. That is along with the rows. Access 0 is nothing but along with the rows. So a lot of things you find when you're working with the NumPy arrays, right? Because a lot of functions are there in NumPy arrays. and there are multiple functions which perform the same operation. Sometimes there are multiple functions which try to do what? Same operation but with slight differences, right? But will you use all these functions? So will you use all the functions means you are learning all the functions. Even the person who work in real time, he doesn't know all these functions because he may use the function which he required. But as a developer, you should know all the functions. And I should know in which situation should be used which function. That is also very much important, right? So np dot concatenate. np dot concatenate. Yes, you are saying arrays, and here you are writing access 0. So, but what will happen when you are working with the concatenate is, see here. So when you work with the concatenate, see here. So here all the access is optional. Actually, this is not access 0. It is what? Access none. Okay, you have to take access none here. Now these are access. So I just take this one. Now some difference. I'll tell you what is the difference here. Now here this is arrays. Arrays. This is about what is the first parameter is arrays. And here access is, actually here access is none, but what is the default is access 0 only. Access is none means what is the default is access 0 only, but in syntax it's not given as a 0, it is given as what? None. But what is the default access is 0, which is nothing but which is stacked vertical or horizontal? Vertical, row wise. And this is what here? Column wise. So if access is none, the arrays are flattened before concatenation. So it will convert into which array? 1D array. Flattened array means what? It will convert into which array? 1D. Let me tell you with an example. So there are two inputs. One is the arrays and one more is what? Access. So two inputs are there. One is arrays and one more is a access here. See here. What I am doing is just observe here. Now you can find the differences. np dot array, I'm saying 1, 2, 3. This is 1D array. B equal to np dot array. Now this is also 1D array. 4, 5, 6. Now C equal to np dot concatenate. np dot concatenate A comma B. It is written in tuple or another sequence. But are you given any access? No. What is the access is? None. You are not given access, right? You are given access is what here? None. Okay, access is none. When the access is none, it is convert this arrays into which array? Flattened array. Means 1D array. But already this is which array? Array. Already this is which array? 1D array only. So it is concatenated 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. I'm taking x equal to np dot array. Now I'm taking 2D array with some 2 rows. Okay, 2D array with some 2 rows and 2 columns. Now y equal to np dot array. Y equal to np dot array. I'm trying to say 5 comma 6, 5 comma 6, comma 7 comma what is that? 8. 5 comma 6 and 7 comma 8. I'm saying np dot concatenate. I'm writing np dot concatenate Here I am writing x comma y. So what is the axis is? None. What is the axis is? None. Are you define the axis or not define? Not defined. So what is the default axis is? None. So it will assume as which array? Array. It is assumed as which array? Flattened array. Z. And here I am using a, yes, I am trying to print this value. I mean arrays x, y, z. Now if you see x, y, z, you can see 1, 2, 3, 4 and 5, 6, 7, 8. But that flattened array when it comes to here, it is added 1, 2, 3, 4, 5, 6 and what is that? 7, 8. But this array is a 2D array or 3D, sorry. Is it this array is 1D array or 2D array? 2D array. This array is what? 2D array. When it is 2D array, when you do concatenation, what is the access I've given? Are you given any access or not given any access? Not given any access. Then what is the default access? None. But if it is 2D array, what is the default access is? 0. What is the default access is? 0. Access 0. Access 0 means it is added as rows or columns? Rows. So you can see here, access 0 default, array stacked which one? Vertically. It is a default. Access 0 is what? Default. When arrays are stacked what? Vertically. When it is comes to which arrays? 2D arrays. So this is access none. It belongs to which arrays? Only 1D array, right? Yes. So if you want horizontally, you just write a P equal NP dot concatenate. Concatenate, you write x comma y, and here I'm writing access. What is the access I'm giving here? 1. Access 1 and I print P. Now this is added as what here? Columns. 1, 2, 5, 6 and 3, 4, 7, 8. But I say no, internally V stack, H stack uses which function? Or internally V stack, H stack uses which function? Concatenate. It means instead of using V stack, H stack, you can directly use which function? Concatenate. Same. Concatenate. That's the reason when you see errors, right? When you run the V stack, H stack, okay, when you see error, you get value error. That value error is raised by which function? Concatenate function. Because you want only horizontal, go for H stack. You want only vertical, go for which one? V stack. You want vertical as well as what? Horizontal, go for concatenate. Go for which one? Concatenate, not stack, not a stack. Go for which one? Concatenate. Stack is change the dimension. This concatenate doesn't change the dimension. It changes only shape. It joins the elements of the array, column wise or what? Row wise. Yes. So that is what you have to remember about this concatenate. Okay, na? Yes. So in the place of V stack and H stack, you can directly use which one? Concatenate. Yes. But the rule is the same. The rule what you applied to V stacking and what? H stacking. Okay. Then the next function what you have is, you understood up to this, right? All of you? What do you say here? Yes or no? So how many functions here? We have seen stack, V stack, H stack, and one more is concatenate. One more is there. What is that? Append is there. Append. Now see, is it arrays? Is it ND arrays mutable or immutable? Mutable. Arrays what here? Mutable. Mutable means what are the mutable operations you can do? Only one. What is that one mutable operation is? Replacing. You can do only what? Replacing of data. Replacing data you can do it, but you cannot delete. You can delete it, but deletion is immutable. Deletion is what? Immutable, because it doesn't delete from original array. It will delete and return that, except that deleted element into what? New array. Except into what? New array. So deleting you can do it, but not from original array. Okay, it will delete and store remaining all elements into what? Another array except that element. So that is what when you work with what? Delete. Now here you have an append, right? If you are working with a list, if we say list dot append means it will add at the end or not? Yes. To the same list or different list? Same list. But here append is immutable. Append is what? Immutable, because it will append. It will add at the end. It will add at the end, but it will add and return into what? New array. But it doesn't do changes in what? Same array. So don't think that append means like a list. It will not do changes in the same array. It will append. It will append and return that append values into what? New array. But it will not do changes in which array? Original array. Original array remains what here? Same. Okay. So don't think that append is a mutable, but append is what? Immutable. You can do only one change. What is that mutable means? You can do what? Replacing, you can do it. Updation, you can do it. But you cannot do deleting. You can do deleting, but that is immutable. You can do append, but that is what? Immutable. When you do append, it doesn't append into the same array, but it will append into what? New array. So those things you have to remember here. Okay. So let us discuss about this, not today, but we'll see tomorrow, like how to work with append, delete, replace, and then we'll see some matrix related operations, right? But not today, but we'll discuss tomorrow, right? Thank you. We'll see tomorrow.